Orrery is a model demonstrating the motion of astronomical bodies. This is my improved version of a design by Dave Koch of the NASA Kepler mission project. I added a fifth planet with 2 moons of its own and made some improvements to the Koch design. Here it is in motion. Here are the 4 planets of Dave Koch's design. And here's my 5th planet with its 2 moons. The moons are driven by a miniature orrery that rides on the end of the 5th planet's arm. An axle running the length of the arm drives the crown gear, and 4 gears of different sizes make 2 concentric shafts rotate at different speeds. The 5th planet moves by means of a second turntable base, located below the turntable of Koch's design. This lower turntable is driven by the green gear you see here. The upper turntable belonging to the 4th planet turns faster, and the crown gear on the 5th planet's arm catches the relative motion to turn the axle that goes to the moons. I used 2 bits of flexible tubing called Flex System and Technic ribbed tubing, both of which are standard LEGO parts. However, I had to use a bit of copper wire to clip the ribbed tubing to the 16-tooth gear and to support the second moon. The sun is a foam ball that came with the RoboSports Mindstorms expansion set. Here's my version of the original 4 planets, based on the design from the URL shown here. I modified the base by adding this green gear. It is driven by a new shaft that turns along with the original crankshaft. If you take the green gear off, the original shaft turns the original 4 planets, as in Koch's design. However, you can leave the green gear in place, and then remove the crown gear from the bottom of the armature and run the 4 planets this way. The green gear is turning the outside edge of the turntable. A small gear on the inside edge of the turntable, which we cannot see from here, is making the other gears turn, which drives the inner 3 planets. The basis of the design for adding a 5th planet is to add another turntable. Here it is running by itself, driven by the green gear. You can put the 4 planets on top of this and use the original yellow gear to drive the central vertical axle, which will make those 4 planets turn relative to the new turntable. The central axle is extended to accommodate the height of the new turntable. The crown gear will be driven by the yellow gear. The new turntable is on now. It should be about like this. You'll need to adjust the crown gear a bit to make it mesh with the yellow gear. Let's put it on the base. I'm going to remove the green gear for a bit to demonstrate a few things about the motion of the 2 turntables. Now we have it running. If I let it run and don't touch anything, the turntables both rotate together. If I hold the bottom turntable, the planets move as in the original design. If I rotate the turntable backward, I can make the outer planets move retrograde and the inner planets stand still. If I rotate it forwards fairly fast, I can make the outer planets revolve more quickly than the inner planets. If I turn it at just the right speed, I can make the planets all revolve at the same rate. So I'll put the green gear back in. Switch it on. The 4 planets move normally, and the bottom turntable is moving slowly. If you look closely, you can also see the yellow gear turning the crown gear inside the base. Here's the arm for the 5th planet with its 2 moons. This is a counterweight. Here's what the bottom looks like. Here is how it fits into the upper turntable. So we'll put the arm with the planet and moons in on this side. Rotate it around a bit. And we attach the counterweight end of the arm to the other side. And here we go. Let's watch it run for a bit. The outer planet and its moons jiggle a lot, mainly because of the flex tube components. Those parts were really not meant to be used as concentric axles. The moons revolve with a ratio of 27 to 40. You can see some colored pegs on the base plate, which I've been using to measure the various rotation rates and try to figure out what the ratios are. They are very complex. In the 4-planet design, it only takes a minute or two for all the planets to return to the starting position. In this design, they still return to a position where they're all aligned, but they've rotated about 110 or 115 degrees counterclockwise in the process. If you want them all to line up in the same position as they were when you started, you have to wait a really long time. So there you have it, a LEGO orrery with 5 planets and 3 moons. I hope you enjoyed watching.